What if you could merge your mind with a computer? Seriously, what if you could control your phone with just a thought? Or what if you could achieve a kind of symbiosis with artificial intelligence? I know, it sounds like something straight out of a movie, but it is quickly becoming science fact. Today, we're going to explore Neuralink, the company right at the forefront of this revolution. And we're going to ask a really critical question. Are we ready to plug our brains into the machine? Let's dive in. You've definitely seen this before, right? The whole idea of downloading skills directly into your brain, it's been a sci-fi staple for decades. Now look, we're not quite at the I know kung fu level just yet, but the basic concept, that direct link between a human brain and a machine, that's exactly what we're talking about today. So here's our roadmap for today. First, we'll get into the basic idea behind connecting minds and machines. Then, we're going deep inside Neuralink to see why their tech is such a game changer. After that, we'll explore the incredible promise this all holds, before we finish up with the really heavy stuff, the ethical perils and the big questions we absolutely have to ask. Okay, so let's start with the big idea. This isn't just some vague, futuristic concept. It's a specific field of science that actually has a surprisingly long history. And the technology at the heart of it all is called a brain-machine interface. A BMI, you'll also hear it called a BCI, is, well, it's essentially a bridge. A bridge between your mind and a machine. And you gotta think of it like a two-way street. It lets your brain send out commands to control a device, and in the more advanced systems, it lets that device send information back into your brain. What's really cool about this slide is how it simplifies the whole process. So your brain activity, those are your neural signals. They get interpreted. That interpretation then causes an action out in the real world, maybe moving a cursor on a screen. And that action creates new sensory information, which then gets fed back to your brain, and boom, the loop is complete. And you know, this has been a long time coming. The journey really started almost a century ago with the first recording of human brainwaves. The term itself didn't even get coined in the 70s. But then, by 2005, we saw the first person control a prosthetic hand purely with their thoughts. Pretty amazing. And then, in 2016, Elon Musk founded Neuralink, with the goal of taking all of this to a completely different level. And that brings us right to Neuralink, because this isn't just another small step. It's aiming to be a giant leap, to create an ultra-high bandwidth connection directly to the brain. So let's take a look at how they actually plan to pull this off. First things first, this is not a simple procedure. The components are microscopic, and the brain is incredibly delicate. So delicate, in fact, that it's beyond the ability of even the most brilliant human surgeon. And that's why Neuralink had to design a specialized surgical robot just to perform the implantation. And this just brilliantly illustrates the scale we're talking about. The robot inserts these impossibly fine electrode threads into the brain. Just look at them there next to a penny. They are so much smaller than a single human hair, which makes them flexible and way less likely to cause damage. Now, using some seriously advanced optics, the robot strategically inserts up to 10,000 of these little electrodes. Its main job is to weave them into the surface of the brain, carefully avoiding any veins or arteries to minimize any damage at all. It is just an incredible feat of microengineering. All of those thousands of threads then connect to this little device right here, the N1 implant. It's a small, sealed chip that sits just behind your ear. It takes all the raw signals from your brain, amplifies them, digitizes them, processes them, and then transmits that data wirelessly to a computer or a phone. You can really think of it like a Fitbit for your brain, but, infinitely more powerful. Okay, so to put it all together, you have a thought, right? And your neurons fire. The implanted threads pick up those tiny electrical spikes. Then the N1 chip interprets what those spikes actually mean and turns them into a digital command. And just like that, you can control a device, totally hands-free, with your mind alone. So that's the how. Now we get to the really good part, the why. This technology is building towards something truly revolutionary. The applications, they start with medicine, but as you're about to see, they definitely do not end there. For medicine, this could be completely transformative. We're talking about giving people with paralysis the ability to walk again or control advanced prosthetics. We're talking about treating mental health conditions like drug-resistant depression by directly targeting the relevant brain circuits. This offers real hope where traditional medicine has often hit a wall. But Elon Musk's ultimate vision, it goes way, way beyond just medicine. His stated goal is to achieve a symbiosis with artificial intelligence. The idea is to create a totally new kind of collaborative intelligence, merging the best of human creativity and intuition with the raw, big data processing power of AI. And that opens the door to a future that feels like it was pulled straight from a science fiction novel. I mean, if the device can read the neural patterns of your thoughts, could it transmit them to someone else? That's basically consensual telepathy. If it can record the patterns of your experiences, could it let you replay your own memories on demand? Could we even feed new data into the brain, giving us superhuman senses, like the ability to see in infrared? This could fundamentally redefine what it even means to be human. But, you knew there was a but coming, right? With such incredible power comes absolutely unprecedented risk. We have to confront the challenges and the profound ethical questions that this technology forces us to ask. And this is the first and maybe the most important question of all. If this technology gives users a massive advantage in life, what happens to everyone who can't afford it or simply chooses not to use it? And that's just the beginning of the ethical minefield. The Royal Society has raised some critical concerns. Could it create a permanent biological gap between the enhanced and the unenhanced? What about privacy? If our innermost thoughts can be recorded, or even worse, hacked? Who is truly in control of a device can literally alter your emotions? And will these systems be free from all the biases that already plague so many of our other technologies? You know, it's also so crucial to remember a healthy dose of scientific humility here. As Professor Jeff Lichtman from Harvard puts it, for all our progress, our understanding of the brain is still in its absolute infancy. If it was a mile-long journey, we've walked maybe 3 inches. And that's really the key takeaway here. Unlike the genetic code, which we've pretty much mapped, we have not yet cracked the neural code. That's the basic language our neurons use to create thought, emotion, and action. So we're building this incredibly sophisticated hardware without fully understanding the software it's supposed to run on. So, at the end of the day, this technology is truly a double-edged sword. On one side, it holds this incredible potential to heal diseases we once thought were incurable and to enhance human potential in ways we can barely even imagine. But on the other side, it carries this massive risk of creating new forms of inequality, new forms of surveillance, and new forms of control. You see, this isn't a question of if anymore. It's a question of when. The lines between our minds and our machines are blurring, and our brains are about to come online. So the real question we have to ask ourselves is, are we as a society ready for what comes next?